Welcome to MLAC online tutorial. In this video we'll be looking at the process of using the first principle. So we will be deriving this expression or equation from this function given here. Okay, so let us assume that this is a continuous function where y is dependent on the value of x, and the changes occurs between them. Okay, so which implies that when there's a change in y, there's also a corresponding change in x. All right, so y equals to the function of x. All right, to that regard, let us now implement an increase in y. So here we have the y now plus an increase in y, which is changing y, then equals f into x plus what, changing x. Now please don't do the mistake of f of x plus changing x. Okay, now this is the fact that the corresponding change that took place in y here affects what, the x. All right, now f here just signify it's a kind of function. Okay, all right, so it's an entity. So to this regard, let us make the y the sort of relation you have changing y equals f of x plus changing x, then minus what, y. All right, so because as y moves over to the right hand side, it becomes what, negative. So at this point, now take note that y equals to the function of x. So let us replace f of x for y in this equation. So you have changing y equals f into x plus changing x, then minus f of x. All right, so let us now divide both sides by changing x. Now this is just the process of the first principle. Okay, so now at this point we'll now introduce our limit, and take note that dy over dx equals to the limit of changing y over changing x as x tends to what, 0. All right, so at this point we can now say that dy over dx then equals the limit. Now take note that changing y over changing x then equals to this function, right? So at this point we will now see here f of x plus changing x now minus f of x, then all over changing x, close bracket, as changing x tend to what, 0. All right, so this is actually the process of using the first principle for differentiation. All right, so now the process here is what we call the differentiation. So from here arriving to this point is what we call what, differentiation. All right, so with this principle now we can use it to solve any differential function in differential calculus. Alright, if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos. Thank you and God bless you.